Vincent Kadiwa. So today I'm going to be taking you through my project for computer vision. It's about enhancing a garden monitoring tool. So in this study, we'll be using two models, one machine learning model that uses naive Bayes, and a deep learning model that uses CNN layers. So now on to the introduction. So we are presented with a video that has various crops in a garden, and the video is roughly 4 minutes long, and we are required to identify 3 crops of our liking on top of grass or weed that is in the garden. So okay, on to the objectives. So I'm going to be explaining how I obtained my data set, how I pre-processed it, and how I evaluated my model in the various metrics. So in the experimental setup, started with the data collection. So where I go obtained various frames from the video where that was showing the garden, and in these frames, they were totaling up to 133. Where I collected the different crops. For my project, I chose maize, bananas, and cassava, as well as weed or grass. So I'm going to be showing you how I enhanced my images, cropping them, and the different kind of filters that I use for feature selection. So as you can see, this is my let me enable a pointer, a laser. So this is I started off with images from frames from the video, which are 133, and I cropped out the various plants of my interest. As you can see in this, I cropped out a cassava leaf. So, and then I applied different filters to and different feature extraction. As you can see, I first converted the image to a grayscale to reduce its dimensionality. Then I applied a Gaussian blur to see how the different dataset looks like, and the Gaussian blur. I also applied the emboss model, the emboss filter, the Sobel filter. So the Sobel filter is for edge extraction to extract out outlines of the various crops, and then as well as sharpening to enhance how the image looks like. So I also did a histogram. So I applied the histogram on all the different 133 images. So in total, my data set grew exponentially. So I got a data set of thousands of images after applying these various features. So these are the classes I've already mentioned them. So then I designed a naive Bayes model. So the naive Bayes, it achieved an accuracy of 70.3 in classifying the crop types. So its precision was 73. The recall was 70 on average, and the F1 score of 0.66 on average. So this was the performance of my naive Bayes model, and then I also updated the CNN deep learning model. So where I evaluated my model on in terms of accuracy and loss. So the loss went on decreasing as the different epochs were being run. So the accuracy went on improving, started off with an accuracy of 40%, but went on increasing up to 100%. So the test accuracy was 100%, and the validation accuracy was 84.62. So the deep learning model performed quite well. So yes, so this is the graphical representation of the different epochs. Here on the bottom, there are the epochs, and here it's the accuracy or loss for this graph. So as you can see, my model performed quite better. The learning rate went on improving, so it converged quite fast, as well as and the loss decreased fast, which is good. So in terms of comparison, the CNN deep learning model performed better than the naive Bayes model, and so there are trade-offs to consider. For example, the naive Bayes model learns very fast, and the CNN model, it took a longer time, and the more the data set, the more the CNN model would take learning. So I noticed that the naive Bayes model has a limitation of features. So it was limited to about 200,000 features. I could not apply all the filters on the knife bias model. So that well could be attributed to its low performance. So my recommendation or conclusion is that the CNN deep learning is performed quite better, especially because the dataset was too small. But I believe as the dataset grows, the knife bias model can also pick up. There was a limitation of the features really. So on each image, I could only extract 200,000 features. So there are a total of 133 images, but I could only extract those features. Whenever I tried to exceed those features, my model could fail to run. And that's the nature of knife bias in general. So yes, these are the references that I used to generate my model, and these are the materials that I used. So this is my GitHub link, and this video is uploaded on this link. So let me walk you through my Jupyter notebook. So yes, so this is the Jupyter notebook. This is the deep learning model. I use the Keras, and this is my layer. I applied max pooling, and I also I used different activation functions. I used Drelu for the hidden layer activation functions, and then for the final layer, I used the linear output. So I tried out different layers. I did hyperparameter tuning, but I found out that this worked better than the others. So as you can see, these are the epochs that are ran on the deep learning model, and this is the loss and the accuracy. So I did the same for the knife bias model. And yeah, so these are the different filters. This is something else I wanted to show you. So for the naive bias, I applied, these are the different filters. For example, the Sobel filter. I came across, I designed a kernel. I used this kernel to get the output that I showed you in my PowerPoint. And as well as for the sharpness, I applied this kernel filter to come up with those results, and the emboss filter. This is the Gaussian filter, and yeah, the other features, the contrast, the energy. So yes, this is how my notebook looks like. Thank you very much.